Hello and welcome to another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 2, Lesson number 5 on one-to-one functions. So there's lots of different types of functions, right? Functions is a very broad class, and within it we break functions up into categories that, share certain characteristics, not unlike what we do with rocks when we break them into sedimentary or igneous or things like that. So let's take a look at a very special type of function today called a one-to-one function. Exercise number 1. Consider two simple functions given by the equations f of x equals 2x and g of x equals x squared. It says map the domain, there's our term domain, -2, 0, 2 using each function. Fill in the range and show the mapping errors. All right, well, let's do f. Now remember, all the rule for f says is take the input and, double it, multiply it by 2. So -2 will go to -4, 0 will go to 0, and 2, of course, will go to 4. On the other hand, g of x, its rule is square the inputs. So -2 times -2 will go to +4. 0 will go to 0, and 2 will also go to 4. We don't put the 4 in there again. We don't list elements more than once. Now, letter B asks, admittedly, a little bit of an ambiguous question. What is fundamentally different between these two functions in terms of how the elements of this domain get mapped to the elements of the range? Well, there's obviously a lot of big differences. You could say, well, function g only has non-negative outputs, whereas function a has some things that are negative. There's lots of different things you could say, but what we're trying to get at here is that each domain element for f of x gets a unique output. In other words, no outputs have been repeated. Now, there's nothing wrong for function g to have an output repeated, right? The definition of a function isn't that every input gets its own output. The definition of a function is every input gets exactly one output. That output could certainly get repeated time and time again. But there are some functions whose outputs never repeat. And of course, some functions whose outputs do repeat. And that's going to be what we're going to look at today. So I'm going to clear out this text, write down anything you need to. Okay, here we go. Let's take a look at the definition of a one-to-one function. So one-to-one function. Now, the technical mathematical definition I really like. It says a one-to-one function is one where if x1 doesn't equal x2, always means that f of x1 doesn't equal f of x2. Now, think about what that really means. This is saying different x's, and this is different y's. Now you might say, what do you mean different y's? Well, remember that it's always y equals f of x, so those are y values, they're outputs. Right? So one-to-one functions boil down to something very simple. Different x values always give different y values, always. And again, there's lots of functions that aren't like that. For instance, take our function, it wasn't f, it was g of x. G of x equals x squared from our last example. That's a great example of a function that is not one-to-one, because different x's don't always have different y's. All right? So we're going to explore functions today that are one-to-one and functions that are not one-to-one. And you'll just kind of get used to them. All right? New category of function. Anyway, I'm going to clear the text out. And let's jump into some problems involving one-to-one functions. Exercise 2. Of the four tables below, one represents a relationship where y is a one-to-one function. Y is a one-to-one function of x. Determine which it is and explain why the others are not. Pause the video now and think about this a bit. All right, let's talk about it. Well, remember, the deal with a one-to-one function is different x's get different y's. Well, here, when we look at these, I look at the four y's and, well, they're all different. So it seems like it could be a one-to-one function. But this thing isn't even a function, right? Not even a function, so it can't be one-to-one. A function, every input, every x value can only have one y value. But in this case, 4 goes to 2 and 4 goes to negative 2. Same thing with 9. 9 goes to 3, 9 goes to negative 3. Let's take a look at choice 2. Well, first, it's definitely a function, so all of these things, all these x values are different. But it's not a one-to-one function because both negative 2 goes to 1 and 0 goes to 1, so repeated y's. No good. Let's take a look at this one. 1, 2, 3, 4, 2, 4, 2, 4, 8, 16. Yeah, that's good. That's good, right? Each one of these x's got its own y, and really, in a certain sense, each one of these y's got its own x's. Well, this is our winner. Let's make sure, though, we understand number 4. Number 4, problematic because we have repeated y's. It's also problematic because we have repeated x's. All right? So, one-to-one functions really have to fulfill two requirements. Every x has to get a single y, and every y can only have a single x that goes along with it. All right? That's why they're called one-to-one. They're called one-to-one because if we look at a domain, then every dot over here goes with a dot over here, right? They just pair up. So these elements pair up one-to-one, kind of like that. All right, pause the video now and write down what you need to. Okay, clearing it out. Let's keep working with one-to-one functions. Exercise 3. Consider the following four graphs which show a relationship between the variables x and y. Okay. Letter A. Circle the two graphs above that are functions. Explain how you know they're functions. All right, well, pause the video now. There's two graphs up there of functions, and then figure out which ones are functions. All right, well, that would be choice 1 and choice 4. So they both pass the vertical line test. The vertical line test, right? You know, the vertical line test that says if we slice a graph with any vertical line, it only hits it once, so nope, right? And nope, definitely not. Now letter B, one of the two graphs circled is a one-to-one function, and one of them is not. How can you explain from the graph? Think about this for a moment. One of those two functions is one-to-one, either 1 or 4. Which one is it? All right, I'm going to go to a different color, just so that we do it. Here it is. This is my one-to-one friend. All right, and it's a one-to-one friend because you can tell that no y values ever repeat. As opposed to, let's say, on number 1, right, there's a situation where two y values are the same, and yet they came from two different x values. All right, so what we're looking for is no repeated y values. All right, and this leads us to something very important. It's what's known as the horizontal line test, and we're going to take a look at that in just a moment. All right, pause the video and copy down anything you need to. Okay, here we go. The horizontal line test. If any given horizontal line passes through the graph of a function at most one time, then that function is one-to-one. All right, this test works because horizontal lines represent constant y values. Hence, if a horizontal line intersects a graph more than once, an output has been repeated. So it's really nice because if we've got some function like this, right, definitely a function passes the vertical line test, right, we can very quickly say, oh, it's one-to-one. On the other hand, if we've got some function that goes like this, definitely a function, right, passes that vertical line test. But now, if we, let's say, draw with a different colored line, this horizontal line, well, we see those y values got repeated. Okay, so we've got the vertical line test, which tells you whether the graph is the graph of a function, and the horizontal line test, which tells you whether it's a one-to-one function. But they do have to be combined together. Let's take a look at the next exercise. Exercise 4. Which of the following represents the graph of a one-to-one function? Think about that a little bit. All right. Well, it's this one. Okay. Choice 3. Now, it's important to note something. Choice 1 also passes the horizontal line test. If I draw horizontal lines on this, they only hit the graph once. But this is not a function. All right, we cannot be a one-to-one function if we're not a function at all, right? It fails the vertical line test. All the rest of these things fail the horizontal line test. Whoops, repeated y's, repeated y's. Only choice 3 is both a function and a one-to-one function. That's a lot of lines. Anyway, I'm going to clear this out, okay? All right, let's keep going. Exercise 5, last exercise. The distance that a number x lies from the number 5 on a one-dimensional number line is given by this function. D of x equals the absolute value of x minus 5. Show by example that d of x is not a one-to-one function. Show by example that it's not a one-to-one function. Now, a one-to-one function means different x's give different y's. Okay. A non-one-to-one function, which will mean different x's, give the same y. All right. So what I'd like you to do right now, and you could use your calculator to help you out too, I'd like you to try to find two different x's that give the same y for this function. Pause the video right now and play around with it. All right. Well, there's lots and lots and lots of great choices, but here's two that work. Let's take a look at d of 2. Right, if I just substitute that into my function, right, absolute value of negative 3 gives me 3. Now let's see if I can figure out another one that gives me 3. Well, let's try d of 8. Right, that's going to be absolute value of 8 minus 5, which is the absolute value of 3, which is 3. All right, and that proves it's not one-to-one. Okay, do you understand why? Right, in a one-to-one function, since these x values are different, we should have gotten different y's, but we got the same y, and therefore not one-to-one. All right. Well, pause the video now and copy down anything you need to, and then we'll wrap up. Okay, here we go. So today what we did is we looked at a very important class of functions called one-to-one. Now you probably don't have a good sense at all for why they're important. We'll start seeing that a little bit in the next lesson. But functions that match an x with its unique y have a very important place in mathematics, all sorts of different mathematics. And again, we'll be playing around with them throughout the year. Thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking. and keep solving problems.